Hello everyone, I welcome you all to this class. In this video, we will solve a few more questions. Let me read the question. As shown in the figure, two tiny conducting balls of identical mass and identical charge are suspended by two non-conducting threads, each of length L. The separation between the balls in equilibrium is x and is related to L as x is proportional to L power beta. If theta is assumed to be very small, then the value of beta is. So here, two identical metal balls are there. Those two identical metal balls were separated by a distance x and they are in equilibrium. When this metal ball is in equilibrium, the forces acting on them will be, see, here there will be tensional force acting on this thread. So that will be resolved into two components, L cos theta and L sin theta. In this downward direction, there will be gravitational pull, that is M into G, force due to gravity. So there are two identical charges of same charge. There will be force of repulsion between the two charges. That force is F. So now we know that L cos theta must be equal to mg, L sin theta must be equal to this force. Then only, see, this force must be equal to this L sin theta. L cos theta must be equal to mg. Then only I can say this is at equilibrium. So that's what I have written. L cos theta is equal to mg. L sin theta is equal to this Coulombic force F can be written as, according to Coulomb's law, K into product of charges. There are two metal balls. I am assuming charge of each metal ball as q. Then q into q is q square. And distance between them is x. That was given in the question. That's why I have written x square. So F is equal to k into q square by x square. So I make L sin theta equal to k into q square by x square. See, in the question itself, he is clearly mentioned that the theta is assumed to be very small. If the theta is very small, then cos theta is equal to 1. Okay. So now L into 1 is equal to mg. That's why I got L is equal to mg here. Let it be equation 1. Similarly, I would like to write this sin theta. See, if you take this theta, what is sin theta? Sin theta is opposite side, that is x by 2. This total length is x. Up to here it will be x by 2. So if I made a triangle, then if I take sin theta is equal to opposite side by hypotenuse. This hypotenuse is L. So x by 2 by L is sin theta. So I got x by 2L. So actually we have L sin theta. That's why this L and this L will be cancelled. I left with x by 2 is equal to, see, L sin theta is equal to F. That F is k into q square by x square. So what I got is x by 2 is equal to k into q square by x square. Okay, now you take this L is equal to mg, then what you will get is, see, I am dividing this first one, L divided by x by 2 is equal to mg divided by k into q square by x square. So if I rearrange this, what I'll get is L is equal to mg divided by 2k into q square into x cube. Just you bring this x by 2 this side, then you will get x cube here. So according to the question, x is related to L power beta. That was given in the question. So if you compare, this L is proportional to, see, L is proportional to x cube we got. I want x is proportional to, if you bring this 3 this side, it will become whole power 1 by 3. So in place of beta, what we got? Beta is equal to 1 by 3. So this is the answer. So option 3 is the correct answer for this question. Three charges 5q, capital Q and minus 2q are kept along a straight line in the same order such that plus 5q and minus 2q charges are at a distance of 2r by 3 and r by 3 from the charge q respectively. See, here you have to remember the same order. So whatever the order that was given, you have to arrange the charges in the same order. If the net force on charge minus 2q is 0, then q is. So I am arranging 5q, capital Q and minus 2q in the same order. And here he clearly mentioned that this 5q is at a distance 2r by 3 from this capital Q. Similarly, this minus 2q is at a distance r by 3 from the capital Q. Now, what he is saying is the net force on this charge minus 2q is 0. So, if the net force has to be 0, the force acting on this charge must be equal and opposite due to other two charges. So, I have to calculate the force on minus 2q charge due to this plus 5q and this capital Q charge. And the net force has to be, otherwise the force acting on minus qq due to 5q is equal to the force acting on minus 2q due to q has to be equal and opposite. So that's why let us assume F1 is the force acting on the charge 2q due to the capital Q. Then K is equal to Q into 2Q by what is the distance? R by 3. R by 3 whole square. Similarly, I am calculating F2. F2 is the charge force exerted by the plus 5Q charge on this 2Q. So then it will be K into 5Q into 2Q by R square. Okay. Why R? See here. From 5Q to capital Q, the distance is 2R by 3. From capital Q to minus 2Q, distance is R by 3. If I add 3R by 3, the distance is R. That's why I have taken the distance R. I have written R square. Now, as the net force is 0, these two forces must be equal and opposite. That's why I have written F1 is equal to minus F2. So, just I am substituting all the known values here. Minus 9 into 2 into k into capital Q into small q by r square is equal to 10 into k into q square divided by r square. So finally, if you solve, you will get capital Q is equal to minus 5 by 9 into small q. Absolutely, it has to be negative. That is clear. Why? Because already this 5q is exerting a force in this direction. Then the other force must be in this direction. For that, this charge has to be negative. Okay. Just to simplify this, how you got this 9? See, r by 3 whole square. R square by 3, 3 is a 9. I bought that 9 numerator into this 2 into k into capital Q into small q. I have written as this. You just multiply this. 5 2 is a 10 into k into q square. Q into q square divided by r square. Just cancel all of them. You left with q, 5q this side and minus 9q this side. So we want capital Q. You capital Q keep this side and this 9 you bring to the right side. So minus 5 by 9 into Q is the answer. So minus 5 by 9 into Q, option 2 is the correct answer. A charge capital Q is to be divided between two objects. The values of the charges on the object so that the electrostatic force between them will be maximum is. So we have a charge capital Q. This capital Q is divided between two objects. Let it be this is the object 1, this is the object 2. So I have divided this capital Q into Q and capital Q minus Q. So if I add these two, finally I will get capital Q only. This minus Q and this plus Q will be cancelled. We got the net charge. So that Q is divided like this. Now what he is saying, now I am finding the force between the two objects what we have with us and they are separated by a distance small r, let us assume. Then F is equal to K into Q into capital Q minus small q by R square according to Coulomb's law. So if I want to maximize or minimize this, first I have to differentiate that f with respect to the variable q and make it equal to 0. So that's what I did here. df by dq is equal to k by r square. See, k by r square is constant, I kept outside. If you differentiate with respect to small q, this small q into capital Q, if I differentiate with respect to small q, so capital Q is constant, small q with respect to small q, if you differentiate, you will get 1. So q into q is q square. If I differentiate q square with respect to small q, I'll get minus 2 into q. I just equated it to 0. So then capital Q is equal to 2q. But what I want is, I want to know the small q value in terms of capital Q. So you just bring this to the side, small q becomes q by 2. So one charge is divided and the charge value is q by 2. Then what will be the other charge? Other charge will be q minus small q. Small q value is q by 2. So both charges I will get q by 2 and q by 2. So option 1 is the correct answer. Thank you all. I would like to stop here.